Hello, Luke here. This is part of the tutorial on building a song detection program, and we've moved on to kind of stage 3 here, where we've built the machine learning model, and now we're trying to figure out, well, how can we use this to actually make a list of moments in time for where songs are on this recording. So how can we use this to actually find the songs? And last time what we did is we built a function that is going to make a prediction about a given moment and ask whether that's a hermit thrush song or not. And it gives us a number from 0 to 1, and 0 meaning it doesn't think there's a song there, and 1 meaning it really thinks there's a song there. And anywhere in between is whatever probability it's assigning to that. So I've got a region here. It's 20 seconds long. It's just at the 300 second mark. And I can see that there's 4 hermit thrush songs on this section of the recording, on the spectrogram. And they're right here, one at like 3 seconds, and then 7 seconds, and then 13 or 14, and then at like 18 or 19. And I just want to point out that this is not a song, and this here is not a song. These are it's a different bird. So it is a song, it's just not a hermit thrush song. And a researcher would be able to go through and pick the correct ones. And the question is our model going to also be able to make that distinction? So what I need to do is sweep through this with some kind of for loop. So I'm going to start off by creating moments in time. And the way I'm going to do that is use the linspace, which grabs like a linear selection of songs, linear selection from a given array. So this is going to be, you'll see as I build it. So I'm going to go from 300 to 320. It's going to grab numbers from between those two numbers, and I'm going to grab 200 of them. So that's going to be every 0.1 seconds between 300 and 320. And I'm just going to do false, which means it doesn't include the 320. And that just means that the numbers work out a little bit nicer. So right away you can see it gives me 200 times, and they're just every 0.1 second. So now I've got this nice list of evenly spread moments that I can sweep through here. So 200 slices of this spectrogram that I can ask the question, hey, does a hermit thrush song begin here? And then what about here? What about here? So that's what we're going to do. And the way I'm going to do that is I'm going to iterate through that. So I'm going to go for time in times. I'm going to make a prediction. And we can go up here and get our function that we built last time. And I encourage you to go back and check that out, how we put that together. Make sure you kind of understand what this does. And it's just going to make a prediction. I need to input the proper arguments, which is actually, they're all kind of correct, except for that one I just changed to song model. That's our machine learning model. And now I'm going to append this prediction to a list of predictions, which I hadn't initialized yet, but now I will. So there it is. And let's say we're going to print the predictions when we're done. And that takes a little bit because it's 200 predictions that it has to make with the model. So that takes a moment. And while I'm waiting, I'll build a plot for that. There, it's done, you can see. I'm going to just make a little plot with matplotlib. It's just going to be a line plot with scattering, and hopefully you've seen this kind of basic matplotlib stuff before. And sure enough, we get our 20 seconds all sliced into 0.1 increments, and you can see there's 4 prominent spikes on this graph, and they actually correspond to the 4 hermit thrush songs. So that's good news. And what we can do is we can zoom in on this. So I'm going to zoom in on one of these just because I want to ask, well, how many are there up here? How many points are on these plateaus? because of course it's just one song, but we're seeing multiple moments. So if I zoom in here on, say, 300 to 305, I get, just this moment here, and you can see it's a plateau of 3 and maybe 4, because you can see it starts to trend upwards at 302, 0.2 or something. And then we get 3 moments in which it's saying, hey, this is a hermit thrush song. And let's ask ourselves just for a moment here, let's ask if that makes sense. Should it have, about 0.4 seconds where it's saying, yeah, I think this is a hermit thrush song? And what I would say, if you think back to how we built the machine learning model, that's exactly what we would expect. Because the positives, remember, they had this little threshold of about, say, being off by 0.2 seconds, where people might have made a mistake on where they selected the beginning of the song. And the misses, remember, I programmatically grabbed all the misses, all the negatives, to feed to the model. And I actually specified anytime you're 0.2 seconds or more away from the beginning of a hermit thrush song. So sure enough, when we run this, that's exactly the kind of bracket we're getting for when it's confident or sure that it's seeing a song. We get about 0.4 seconds, so 0.2 on one side, 0.2 on the other side. Roughly, remember, it's not going to be always nicely centered because it's just sweeping through this at 0.1 seconds. So it's not necessarily going to get the very beginning of this song or this song. It's going to be off by potentially 0.1 seconds, right? So we're seeing that there's about 0.3 or 0.4 seconds in which it gets confident, and then confident that there's a song, and then it drops off. And that's what we would expect based on the parameters we chose for our training data. And that's good. Like that doesn't mean we chose the right number, but it means that it's behaving as we would expect it to. So that's a good thing. And I think I'll cut right there. And really on the next video, all I'm going to do is trying to keep things short here, but I'm going to just show how we can get song stamps or timestamps from these plateaus. Because of course, right now, if we just said we want it anytime there's a 1 or anytime there's close to 1, give us a timestamp. Well, it's going to give us a whole bunch. It's going to give us 3 here and 4 here, and this is actually just one song. So we got to just think a little bit about how that's going to work, and that's what we'll do next time.